Yeah, I'm on GitHub and Blue Sky and Fosstodon. I try to check Fosstodon every now and then. Um, all right, so the first time a song was played from physical media was about 150 years ago, almost. Mary Had the Lamb, and somebody probably sang along with it. All right, so does anybody here ever sing any karaoke? Don't lie. Okay, good. So the first machine was actually made in 1971. But after that, like the 80s, it started spreading around. By the 90s, it was everywhere in bars in US, Europe. But the real hero was this, the CD+G. All right, so this thing was developed or the graphics part of it was developed in 1986. So you basically would have these CDs, and they're regular audio CDs, but they also have some graphic capabilities on them. So you could play it, just the music, in a regular CD player. And this format's still very much around. So the way they would do it is the CDs, they're mostly audio, but there was in each sector some bytes set aside for some things like, and this is every audio CD, for timing, but there was also about 72 bytes per sector dedicated to nothing until in 1986, they started putting some graphics information in there. So this is what that actually looks like, right? So about 2.27% of each one of these frames is dedicated to graphics on a CD+G. Now, normally you would think, right, like graphics and like movies are a lot bigger than audio, right? So this is what we're working with. And what that works out to about on, let's say, a 700 meg CD, 80 minutes of audio, is about this much bandwidth that you have for graphics. So less than a dial-up modem, right? So our graphics look like this. Okay, so if anybody has been to a karaoke bar and seen this, that's the reason. So they look like Atari because we have a very small resolution that we're working with. You can get 16 colors at a time. Although you have a pretty good selection of colors, 4096, but only 16 at a time displayed on the screen. You're rendering things in tiles. It's actually a lot harder to do this 9 years earlier on an Atari 2600 by putting up graphics. But just know we're not working with much data, so they're kind of doing what they can to give us some images. Oh, by the way, this right here, it's like, okay, that didn't just blit right onto the screen. That's about a 4-second wipe to get that much of a picture. Every now and then you'll see a really elaborate picture in karaoke, and it takes like 10 seconds to get across. All right, so those instructions on that CD that are fit into those little bytes are actually, there's only 6 things that you can do. You're basically just putting tiles around, you're clearing the screen, things like that. Really, really simple. But this format isn't dead, and why isn't it dead? Well, because hundreds of thousands of songs, or at least over 100,000 songs were made like this. There were some pretty popular producers of this music. The files that we rip from these CDs, and we take MP3s from a CD. We also take the CD+G, which is that data. And between the two of them, you got a reasonable file for a karaoke song. And most karaoke jockeys have a giant collection of this stuff. All totally legally acquired, I'm sure. All right, so we should be able to do better than just that, and we can. Somebody might be, wacky enough to say make a CD+G graphics reader in JavaScript, in which case you can put, instead of just that little 4:3 aspect ratio, how about put a 4K display behind it, put that web audio through something to analyze it, do something like Winamp, right? Like do a bunch of stuff with the music, so you can see the beats and whatnot. And when you have 4K, doing like WebGL or WebGPU or whatever stuff with the GPU in 4K behind some really crappy graphics, the overall effect, well, this isn't a really great representation of what it can do. You kind of get the idea that we can get like full screen 16:9, center the graphics, and do all of this. And this was actually made possible because of the foresight of saying, well, and it might have just been because of the constraints that they were under, we need to have a code to clear the screen. Well, so what that means is these things are basically transparent. Just don't do that screen and put something else in the background. All right, so we could do all of this, and this is big improvement on what we had, and we can reuse all this music that's out there. But of course, we have to get into the AI stuff. So once a month or so, I DJ on a bike. I've got a big cargo bike, and play music on it. So when you're DJing, if anybody here has never DJed before, you have some turntables in front of you. You've got one song on one side, you've got one song on the other side. You want to mix the two songs, right? So what DJs would really like to do is maybe turn the vocals down on one, maybe turn the bass on the other. So when you're mixing, you can kind of bring in one part of the song and the other. And vocals are typically like in the mid-range, so they might turn the mid down. Bass is the low range, you might turn that up, stuff like that. But it'd be really nice to just say drop the vocals out, or drop the drums out of this one and mix just by getting these things moving about the same tempo, but only taking the parts you want. So you can take Taylor Swift and put her in a Tupac song or something like that. You can just sort of mix these things together and make new things. So in order to do that, in the past, you'd have to get these recordings of the songs that were very expensive, where they segmented out and they said, okay, here's the drums, here's the vocals on different tracks, and you could do that. But it's over the last 10 years, we've been working on doing this in AI. So 10 years ago was pretty early, just attempts of separating this music out. So taking one audio stream, one thing of PCM data, right, just this waveform, and trying to pull the little components out with AI. By 2021, we got pretty good at this. Now, a lot of DJ hardware or DJ software will do this in real time. It's still a lot better if you are able to do this ahead of time and put a really good, strong model at this versus trying to do it in real time. But even in real time, the separation is good enough that you can do some really interesting mixing with it. All right, so we separate the tracks, and then what do we get? Like you had an MP3 file for your music you took off a CD. So with stems, what is it? And MP4 is a way of doing this. You think MP4 is for movies, right? That's what most people would think an MP4 is. But an MP4 is just a container. What it has inside of it is tracks. These tracks have some codec. It could be, FLAC. It could be OGG. It could be anything. But those are the audio tracks or video tracks that are inside of this MP4 container. And so Native Instruments, they make a lot of music equipment and DJ equipment. And they put this standard out there a few years ago that says, okay, we're going to put stems inside of MP4 containers. And this is great. And what this looks like in practice is you've got a song, you probably name it .stem.m4a. M4a, MP4, they're actually both containers. This is just a convenience to let people know, hey, this one's probably audio because it's .m4a, but it's the same thing, same type of file. And in there we have a master track, which is like the whole song, and then a bunch of other tracks, drums, bass. Other is just like the catch-all. It's usually guitars and keyboards and synthesizers and all the rest of it, and vocals. And of course, there's some metadata in there. And in an MP4 file, we call the metadata an atom. So we have some atoms as metadata. So what would that have to do with karaoke? Well, this is great, right? Because we can just say, I want to play all of the music tracks and not the vocals, so I could sing. Or maybe I just want to hear the vocals. Or maybe I just want to hear the drums and the vocals. So we can kind of pick and choose, which is great for karaoke, in order to pull out the parts of music because you're adding to it. All right. So how do we actually make the stems? Right, so what do we do to actually do this? Well, there's an open source model from Meta called 𝐇𝐚𝐥𝐿, and this one's really powerful. It's open source, it runs on PyTorch, which isn't great for me, but it's fine, and it's trained on a gigantic data set of music. So it's really good at separating these things. In action, right, we're running Python, we're giving it this executable, which has the model in PyTorch. We give it a wave file, and that wave file becomes these four pieces: vocals, drums, bass, and other. And like I was showing you before, we have this thing, this mix down, this track. Well, that's our original track, so we can make one of these files, right? We can say that we have a MP4 file that is the original, plus those other four pieces. So let's hear what this sounds like. This is a web-based version that I just worked on. And here's a song that was commissioned just for this event by an artist named Montes. Okay, but we can do little pieces at a time. That's just the drums. Let's bring in some bass with those drums. The other instruments. And let's hear this clanker sing here. Okay. There's actually one part that I like. I don't know why. To the back row. Okay. So yeah, AI is not just coming for us developers. It's coming for everybody. All right. So cool. Let's. We'll play it again. All right, but what about the lyrics, right? So cool, I got the music. I can now separate these pieces. We obviously heard the individual parts of this thing. Well, I said we have atoms, right? We've got these little pieces of music. So the standard atoms are like, the artists and the stuff, the things that we used to put in like ID3 tags way back in MP3 files so we know who it was, what year it was, all that stuff. So metadata. And that is just standard MP4. That's been around. Stem atom came more recently, and this was just some more information about those stems, and that was put out by NI. And then this guy that hangs around heatsink a lot decided, let's do one more atom. We'll call it Kara, because I like 4 letters, I guess. And Kara is a place for us to put lyrics, right? So let's put the lyrics into the MP4 file. And then we have a karaoke song, right? We've got the different pieces. We've got a place to put this stuff. It's compatible with everything. If your player doesn't know anything about how to play the stems, it'll still play that main track. That one that I just showed you, if you don't happen to have a web-based stem separating audio player, you can still hear it like a normal track. All right. But that didn't tell us how do I actually get the lyrics, though, right? That's just cool. If you have lyrics, jam them in the Kara atom, and you've got a karaoke file. There's another model that I'm going to introduce here just to throw some more AI at it. And I don't know why every AI company does that with their logo, but whatever. Whisper is a model from OpenAI. Now, this is trained on speech recognition. Lots and lots of audio is put into this one. Multilingual. It's great, but one thing it really does neat, it doesn't just give you the text, it gives you the timing on the text. Because if anybody sung karaoke and they had one of these old files from one of these things and you notice, hey, that's not exactly the right timing and it throws you off, Whisper will help for us to get the lyrics and to tell you when they happen. So now you really do have karaoke. So what does this produce? Well, you give it some audio, like a vocals.wave, and it's really cool because we've already isolated just the vocals. One thing that's hard for models to do is to take an audio stream and get text because you've got potentially music in the background. You got somebody's guitar playing. If you strip all that out, just leave the vocals, these things are a lot better at getting just the words out of the thing. Okay, so we've got all of those pieces. So our pipeline now to make karaoke, we take any song, we run it through Demux to separate the pieces. We run the vocal piece through Whisper and we get the lyrics. We put all that together in an M4A file. Now we have a karaoke song and everything is perfect and this just works, right? Except that Whisper was trained on speech, not singing, sometimes a problem. Sometimes the timing is off. In fact, the timing, it's like, yeah, it got that sentence about a second away from when it started, which is fine if you're just going to compare it to the old karaoke because it's kind of the same. The things don't line up exactly. You see the lyrics. And if you've heard the song before and you know how it goes, you might not be staring at the screen anyways. So all of that is fine. But what if we wanted to remove this additional friction here of not having the things line up or guessing the wrong lyrics? Are we toast? I asked the chat if I'm cooked. He says, no. They're going to help us out. Okay, so we can fix what Whisper did with an LLM, a few ways. We can tell the LLM, here's the real lyrics. We don't have the exact timing for that version of the song, but here's the words, figure it out. I'm giving you the timings. You just make corrections. Maybe look up the lyrics. Also fix language things that could be weird. So LLMs can help with that part. And well, here's some examples. If you guys have ever heard of Jimi Hendrix or Elton John or Nirvana, this is the sort of thing it does. Because the way you hear things wrong, it turns out Whisper does the same thing, right? And so the LLM goes after that to clean that part up. All right, so I'm going to put this all together. I've been working on an open source thing. This is on my GitHub already. And why is it called that? Because it's Louie and karaoke and AI, and that's what the Clanker told me to call it. But it's open source. It plays these files. It also supports the old format. It's cross-platform, so all the things. But it also lets me create these files within the editor. So since we already know we got all these open source pieces to do all of this, we can take 𝐇𝐚𝐥𝐿, Whisper. Crepe is one more piece I didn't really go over, but it's to, some people care about the key that a song is in, so let's use another algorithm to figure that part out, do the LLM correction stuff. In the end, spit out one of these stem files, these M4A, MP4 files. All right, real quick about the whole tech stack around this thing. I just want to mention sort of the pieces because if some of this stuff sounds weird and it's like, you know, you do front end stuff mostly. Cool. All of that stuff still applies to the way this thing is built. I help maintain a website called You Might Not Need Electron. And yes, there is some shame here, but I haven't figured out how to get PyTorch to run yet inside of a browser. That's kind of a big one. It likes to use CUDA. It likes to use a whole bunch of things that are just really heavyweight. But if anybody wants to help me with that, I would love to have PyTorch in WASM running these models all on a web page. It would be fantastic. So anyways, these are the pieces that make up this app. All right, so let's take a look at the app real quick. Sorry, I hope I'm not speaking too fast. I don't know how I'm doing on time here. But it would have been a lot faster if I didn't kill the app right before I came up, right? Okay. All right, so let me take you through real quick what this thing does here. So obviously these are like, if anybody's ever used any karaoke software before, all of those features. And a library of music. And this is the important part though, if you just want to get started with something like that. So IEM in audio means in-ear module. And with this type of karaoke, we want to play the music through the PA, right, which is outwards. But we could also play the lyrics in your ear. So anybody sing when they're driving, right? You sound really good when you're singing along, right? You do. You're fantastic. Every one of you. Between you and Beyonce, you have a combined 35 Grammys. So remember that. But what'll be really, really helpful is if that singer is in your ear, just their voice, everybody else hears the music and your words. So we could do that by taking the vocals and passing them back in. Okay, so anyways, we could route audio however we want. These are actually effects from Winamp, really whips the llama's ass. These were taken from that, converted to WebGL, and I snuck them into this app to give us those background effects. And you might have noticed the QR code on here. And I'm surprised I haven't seen any requests come through already. Too late. And some server setup so that when you hit that QR code, you can ask for a song. But here's the big one. This is why I need Electron. So if I were to take an audio file from wherever, legally acquired source for my MP3 file, and drop it in here, the reason it's an Electron file is because it's bundling all that Python stuff, and it's huge. 𝐇𝐚𝐥𝐿 is a large model. Whisper is a large model. And but this is just sort of packaging it up together. And even if the LLM didn't fully correct things, we of course could take that song that we just showed, and let's see if this works.
Flying in, there's a sun, name tag swing, laptop done.
Okay, can that stop?
Flying in,
it's not going to stop. We got to hear this whole line.
Name tag swing, laptop done. Oh, my key, spelling out your name. Just a glow, glad you came.
Okay, so we can adjust the timing if we need to because Whisper isn't perfect. Like obviously there's a second or two up here in front of this one, but it's good enough. So if we want to look at that song. So by the way, I just at 2 in the morning made that song. Me and my buddies in the garage with our equipment, we made that song. Let's load it up. I'm not going to sing this, by the way. This is how it works. And full screen. If we do want to hear that other person sing along with them, we just bring the ends back in.
One day only, all in one room, close enough to feel like he is blue. Phoenix, see, cool crew inside, you got the name outside. Sit down, stand up, talk go, crack the smile. Do tricks, stick clicks, stick around for a while.
Okay, that's enough. All right. Thank you. Thank you, Clankers. Oh, do I got requests already? You have to come up and sing. Oh my God, there's already 4 requests. Approve, 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 approve. All right. What was I at? Back on my slides here. All right, so most of the things I want are in this, but I'll invite everybody to collaborate on these repos if you want to help out. But what we're able to do here is make AI-generated stems from any song. You could go with your phone, hear somebody recording, or hear somebody playing the guitar on a street corner, and you can make a karaoke version out of them, right? It's any audio stream that we can pull the stems out of. Now, you're not going to get lyric correction from an LLM because they have no idea what that guy's song is or that person's song is, but we can, in theory, make a karaoke version out of anything now. There's a few more features in there. We've got... because we have the pitch that I'm getting, the key, all of the metrics I'm taking on the music, we can auto-tune. We can bend your voice towards that other waveform. It's a little weird, and it's not great yet, but it's getting there. And we could vocal coach you and tell you, hey, you're really far off of that singer. We could make you, hopefully at some point, sound exactly like that other horrible singer, and you guys will both sound exactly the same. So there's a lot more that could be done here. But I think right now M4A is a good enough successor to CD+G. In my own head, there is nobody else as far as I know, but please, I don't know of a better way to do this for karaoke because everything else out there is pretty much proprietary or using the old stuff. But this is just built on top of an open standard, and we just sneak lyrics into that. And if you want to see where any of the stuff is at, there's when you take a picture of this one here. I'll put on my socials. I'll put the links to all this stuff. So Luca is the stuff, the karaoke, but I've got some other AI stuff going on, some retro gaming stuff, all of that. These are the current projects I'm kind of working on right now. And that is it. All right. Thank you.